Alright guys, I want us to do a recap here. Okay, now let's study this schematic. This is K1 for mains, that is utility. This is K2 for standby, that is genset. This is K3 for inverter. Take note, if the inverter is of three-phase inverter, you don't need this loop. You're going to be direct just like this one. You're going to be on this form. Four lines will supply here input. The supply of this will be 4 lines if this inverter is three-phase. But if this inverter is single-phase, it's only live and neutral will come here, then you loop here. The reason why you must loop here is because you are going to distribution board. The load is supplying to distribution board, and distribution board, you must feed DB with 3 lines and neutral, that is 4 lines. Okay, whether it's single phase or three-phase, but you are using DB on your distribution system in your house, in your office, anywhere. Provided you use DB, it must be 4 lines will supply the DB power. So because of that, I must loop here to still produce 4 line out at the output side of the contactor. That is the essence of looping here. Okay, but if the three-phase of the inverter does not have three-phase, you loop it this way. But if it is three-phase, it's going to be this form. Okay, hope that is taken. Then we are using this load to simulate the output so that once we simulate, this lamp will come up. Now, when you have supply 1, supply 2, supply 3, you're going to loop them at the back. Loop them line 1 to line 1 to line 1, line 2 to line 2 to line 2, line 3 to line 3 to line 3, just like that. Then neutral to neutral to neutral. That is the load. Now, supposing you want to alternate 4 independent power, 4 instead of 3, the same thing applies. Just copy something like this. You're going to extend another line here. Okay, and loop them the same way. It's as simple as that. And loop line 1 to line 1, line 2 to line 2, line 3 to line 3, then neutral to neutral. It's as simple as that. If you want it to be 5 different alternate line, you produce another one here again and synchronize all of them. All of them, anyone that closes will produce this load. All right, I hope it's clear. All right, so if that is taken, now I want us to design a control. All right, pay attention please. I want us to design a control because in a schematic, in a design concept, in a design principle, global standard of designing principle stipulate that control circuit should be separate from power circuit. Because if you want to wire this place, taking cable from here to later everywhere will be so complex. You'll be confused. So because of that, power circuit is going to be different, then control circuit is going to be different. So what we're going to do, I will change this. Okay, let me tell you how I'm going to change this. I hope you will understand it. Look at it. Let me change this diagram here to what we call a structural represent like organogram. Let me do it like organogram form. I'm going to change this control circuit. I mean a power circuit. I will change it to be like organogram form so that I will reduce the space of this place so that I can put control, because I don't want to put control in another page. I want control to be the same page with this so that when we simulate, you will see how this one will close. Okay, ideally you're supposed to have control in another page in some cases, but because you are just a beginner in design, I want you to be seeing your control diagram together with your power diagram in one page. But how do I now miniaturize this design so that it will reduce space so that we can put another space, use another space for control? Want us to maximize the interface to contain the two. So I will change this. Let me change it now, and so that space will be reduced. Okay. Okay. Now I want it this way. I hope you'll not be confused with what we have here. Take away this. We don't need this. I just showed you how to make it for alternate power. Okay. So take away this. Let's work with 3. Even if you want to make it 10, that is the format. All right. Okay. Now I want to delete this. Then let's work with this. This one is what we have here. 1, 2, 3 is this 1, 2, 3. If any of this one close, I will have output at my load. This is my load, this load. So we are going to be simulating with this. So let's take away this so that we maximize this, minimize this space, and also maximize our output here so that all of that will fit in. All right. So what we're going to do now is to start designing control. I want to give you conventional ATS again. I want to do a recap, but this time we are adding inverter. Okay, exactly what we have done before is what we want to repeat again, but this time we are adding inverter to make it 3 source of power. I know I posted the schematic to you, but I know you will not study it. So in that case, I want to make a recap. All right. All right.